So I want to let everyone know that as we were preparing to get Paul on the show, talked to a number of different Siemens people, and everyone's has Paul told you about this crazy stuff that he's doing with beef production? Has he
Yeah.
told you about like the digital twin for the next generation of the cattle industry? And I think
Yeah.
that's basically
I'd
been
love
everyone's immediate feedback when I told them that you were coming on the show, Paul. Can
to.
you give our
Yeah.
listeners maybe a bit of an overview and some
Yeah.
of the excitement of what you're doing?
Thank you for that. And I'm a passionate fellow, even 30 years plus into this industry. But yeah, so my first project I want to talk about, it really addresses what we discussed a little bit earlier, supply chain
Yep.
sustainability. So just to give you some sort of interesting facts I pulled up and ready for today's call. If you look at the Food and Agriculture Organization of the United Nations, they've released a new estimate that livestock produces 11.1% of global greenhouse emissions. Here's another interesting one. Late last year, the Irish Department of Agriculture proposed to kill 200,000 to combat climate change and meet the EU climate objectives. Some supporters of this proposal liken farms to factories. And similarly, the Dutch government is also considering a plan to reduce nitrogen pollution caused by manure from 100 million animals on the country's farms. And if we turn our attention back here to the US in 2018, approximately 25 million cattle for beef were sent to abattoirs for feedlots. And so it's really interesting. Unfortunately, these rather cute critters have got a bullseye, no pun intended, over their existence and being. As I like to
Mhm.
call, there's a beef industry call to action. What can we do to really move forward with using automation, using intelligence, and the best practices that need to be leveraged today to address some of these issues? So for us, we look at supply chain. We said, how can we use smart herd management and automation to shift the animal feed regime? And this is really interesting, from generic days on feed effectively to days required to achieve a production specification. I don't know if you're aware of this. Animals arrive at the feedlot, and basically we said we're going to feed them for 200 days. And basically we feed them, and 200 days later, we choose to ship them off unless there's been some kind of health concern or issue. So when you step back and you think about this, it's actually quite interesting. By bringing animals to specification or identifying non-performers early, feedlots can optimize their resources, reduce emission. Younger animals produce less methane and consume less food and water per animal. If an animal meets specification 20% earlier, you avoid most emissions and the most emissions and resource intensive period of its life. So that could be an interesting angle. Think about that. Instead of days on feed, let's actually look to move to specification. How does Siemens propose to do this? We're using what we call our accelerator program. It's an ecosystem partnering
Okay.
program. And right now I'm collaborating with an Australian smart meat eating quality sensor manufacturer. And these guys, you'll love this, have developed an ultrasound sensor specific for the task of basically assessing cattle in feedlots. The sensor works by combining AI machine learning models and algorithms to be able to measure and predict the intermuscular marbling and other key meat quality metrics of live cattle as they enter the feedlot. So here we've got a tool now that we can basically, it's really, if we think about it, it's ultrasound, which will look to see our unborn children. But effectively, we're now looking at it to basically measure and see how this animal can behave, or it will finish, as they refer to it in the industry. So using this sort of Siemens, and again, what's interesting, using our outdoor automation rated products and really an edge computing, because that's effectively what it is. It's a mobile device that sits out there where the animals are incoming. We're able to provide really actionable intelligence. And what's nice is, how can we use this information? So here's an example. A truck of animals arrives. Immediately, we basically take a measurement. We can basically identify almost as soon as the animal arrives, non-performers. And also, too, we may have cattle that's already reached a specification need. So that could be quite interesting. In the short-term view, we can be looking at the feed regime from moving from generic days on feed basically to achieving a specification, which will be based around, let's just call it what it is, prime, select, choice, which are the different meat quality grades. Longer term, we can look at reducing feed and water while still achieving the same animal specifications, therefore reducing the volume of resources required. And then longer term, and this is where it gets really quite interesting, and this is where information management and really AI, machine learning, and really traceability come in. We can identify genetically suited cattle for the feedlot environment to approved health, eating quality, and time on feed. Because as I mentioned earlier, the bigger the animal, as you can imagine, the bigger those country pies that it drops each and every day, and the fact that the gassier the animal is, and obviously they get thirstier as they get bigger. So here's a great opportunity where now we can provide tools to imagine 25 million animals on a 200-day feed regime. Now we can basically be measuring them and actually making key decisions about sending animals to the next phase of the meat packing process, but in a way where I can now basically calculate and basically reduce water, reduce feed, and basically optimize the production of that unit of protein effectively.